Hi everyone, welcome back to this series. So here I just have an example folder, just an empty folder. What I'm going to show now is the build system. So the build system is probably like the final boss of Zig, honestly. It's probably the hardest thing. You don't normally need to use it. I'll probably make another video how to simply just make a release build without having to deal with the build system. But say we want to, the main reason you want to use the build system is either you want to link a library or you want to use it and build for different platforms. So the problem with like building for C programs is you normally have to build it on the actual, say you have an ARC64 Linux operating system, you want to build for that, you have to have an ARC64, or you have to like emulate an ARC64 with Linux and then build it on that platform. So Zig has inbuilt a way to actually build for every one of those platforms, doesn't matter what platform you're on, which is a very cool thing and a very complicated thing actually. But say if you want to just make like a build, so as usual, just hold shift, right click and go to PowerShell and then you just type in Zig and it will give us the commands. What we want to use is init. So Zig init. So I'm just going to type in Zig init. This will create a setup for basically a way to build. And if you want to build from this, simply, if you want to just like run it, you just type in Zig build. And that will do it. If I can, it's not going to let me scroll down, but it's doing stuff. And then Windows Defender also complains for some reason. But that will build it for you in Zig out, and it will be bin example. So we have example.exe. Let's go /example.exe. Be all your code base belong to us. I belong to us, the standard joke. Which is basically, yeah, because in the main file, that's what it says. In the main file, that's what it says. Alright, so that's just, that will build. I wouldn't normally do that, but say you want to build for multiple systems. So I have a already done. Here's one I prepared earlier, kind of thing. So here we have in the main folder, it's simply, I'll show you one Visual Studio Code actually. I'm not sure if I have it open. Maybe I do. No, sorry, this is another thing. Alright, so in the main file we literally just have sc.print. You have finally conquered the build system, because the build system is ridiculously complicated. So I copied a lot of this code. Let me close it. I don't know why it has to open literally everything. So I just copied a load of these. Okay, right. So we get to build. I actually copy this code. The default, I think, is a bit different to this. But what I got this from, I'll show you where I got this from. Yeah, I got this from the actual main site, generating files, build system, which has this code and has this, which I didn't really understand what the hell this is. Like, what the hell is a std.target.query? It's one of the main things main problems I have with Zig a lot of the time is like, what the hell is that? Like, what is this? And you got this weird syntax here as well, which basically is a way, I believe, to create a slice. If you use @dot, you create a slice this way. I believe that's what it means anyway. So I copied this, and I didn't want to use this because I didn't actually understand what the hell this meant. So I went through this massive went for this massive rabbit hole of trying to understand what the hell this actually meant. So what a query is, so in the standard library we go to std.target.query, and it's this file, which I'll again open in VS Code, please, so I can actually see stuff. So VS Code has a CPU architecture, CPU model, and what this is actually using is it's using this weird function b.resolve, and you're not going to let me click on it because it's a really annoying program. So we're going to go to build, because it's in a B as a build. So we go to build, and we go resolve target, and it's not going to find it. That's fun. How is that not finding it? I'm going to look for resolve. So apparently for some reason I can't find it because something's broken. I don't know why, but basically what this does is it turns this query thing into a target which has some data like the CPU, the operating system, and stuff like this. So you don't really need to know this. You need to know, all you need to know is you do target.target.b.resolve target query, then you put in a target.query, this thing, whatever this is, which is basically like it's basically a file but acts like a struct. You should think of it like a struct. Here I decided to make a load of CPUs. I think, oh, I didn't actually, before I made loads of CPUs, but because I was trying to work out how to do this. Basically, you want a thing called CrossTarget, and CrossTarget is in, so it's in std.zig.crosstarget.zig, and a CrossTarget takes in a CPU architecture, CPU model. A lot of these are actually predetermined. The only thing you really need to care about is the OS tag and the CPU architecture, and most of everything else will be automatically done for you. So you put in the CPU, and I've just had a load of these. So I've got like Linux x86, Linux x86-64, Linux ARM. I'm not sure if Linux even uses ARM. I have no idea what. I'm not really an expert on CPU architecture, to be honest. And then we have Windows ARC64, oh, sorry, Mac ARC64, Mac x86-64. And then we have Windows 8 x86, Windows x86-64. So basically, you just type in. So this CPU architecture is a CPU arc. It's basically an enum of all this. So if it's ARC, you put in ARC64, ARC64. If it's x86, so basically just put in dot. On the reason I'm using Visual Studio Code, it will actually help you. So you type in dot, and it will give you the x86. This is x86-64, so x86-64. Alright, and now I have a for loop, for targets, just using an iter and iterating through them, for targets, target, and I'm going to put the target in here. I actually have no idea what this is doing, but you don't need to care. Honestly, this will work. This will just run for all of these. So I'll show you what this is like when you run this. Alright, so there's a few things you can actually do. So you say, for example, zig build help, I think it's called, dash help. If you do dash help, I think it will give you a load of stuff. Apparently it won't, because I don't know what I'm doing. Apparently it's dash help. Yeah. So you do dash help, and it will give you like literally the most amount of commands I've ever seen in a thing. Like, this is so complicated. So you have like prefix, release mode, darling. What? I don't know. I don't care. So what I'm going to do is I'm just going to zig build, and I'm just going to go summary all. And this is going to give me all the information. So summary all. You just do zig build, and it will do this for you. So what this is going to do is just simply, it's going to show me information, but it's just going to build for every system. The thing is, I've already done this before, so it's cached everything. So before the first time, it will be a lot quick. It'll be a lot slower than this. As it's cached everything, it doesn't matter. So what this has done is gone to zig out, and we have all of them here. And I can't see anything like this. So we have all of them here, right? So we have this main. I don't even know what file this is. This is a .file. That's a macOS ARC. Main ARC. That's Linux ARM. x86. x86 Windows is a main.exe. x86-64 main.exe. So I'm using Windows. I can't test if this actually works, but I guess if you have a Linux machine, you can test this. I can't, so I don't have one. But that's basically how, if you want to build for different platforms. So I'll just go through this again. So we have the CrossTarget, which takes in a. You could also do what on this site was this weird stuff. So you could do anything like this. Targets weird. That's what I'm going to call it, because it's weird. Which takes in a struct of a std target.query question mark, whatever that is. You could do it this way if you want, and it just do dot that. But I don't really understand what the hell this means, so I'm just going to make it a cross target, and it does the same thing. So I don't care. So yeah, you just put in the CPU architecture. In theory, you could do this if you wanted, like this, and just say .cpu architecture .cpu arc equals .x86. You could do that if you wanted to. .os tag equals .windows or whatever it was. I don't remember. You could do it like this if you want, but easier to build it separately, I think. If it would give me what I just had, that'd be nice. Okay, it's already there. So you can do that if you want. But that's basically the basics of how to do it. And then you just loop through all of them and then put in the target each time. You can also, if you want to change the optimization, you can put in here, you have release safe, you can put in, there's 4 different options. So there's release fast, release safe, release small, and then debug. And I believe you can actually go to these. If you click on this, it will, yeah, it'll be optimization mode. It's one of those. All right, in the next video, I'll probably show you how to just do this without a build system. But anyway, so that is how to build 4 different operating systems. This is extremely complicated, actually, all this stuff, because I don't understand half of it, and it took me a few hours to actually work all this stuff out. But let me know if you have any questions. It's quite complicated stuff. See you guys next time.